Good afternoon, beloved congregation. Welcome in this beautiful church. And since we're in this beautiful church, I want to restore a small but very old tradition. And that is, before we start to contemplate, read the Ten Commandments. I think that's no more than appropriate in this place. So bear with me. Thou shalt not murder. Thou shalt not steal. Thou shalt not force push. Thou shalt not file issues without minimal reproduction. And finally, thou shalt not use proxy. And this is the thing we're going to think about this afternoon, about not using proxies. How are we going to do that? By talking about proxies and how awesome they are, and then we are going to conclude that you shouldn't be using them. So first we're going to talk a little bit about Immer and immutability, and then we're going to dive a little bit deeper on how this all works. So what is Immer all about? Let's go to a quick demo. I have here a quite classical reducer, and I have a piece of state on top. So over here, and then there's a reducer that accepts an action, and I implemented only one of them, and that is adding a tag to a specific to-do item. And so that means that I can call the reducer with the initial state. I can give it the action it should perform, and then in the end, we should have some new, updated, but immutable state, some immutable data. And we actually verified that this implementation is correct by having a few small tests. We state that the old state wasn't modified in this process. We state that we produced a new state in which the tag does appear. And we also state that the things we didn't change, we want to be sharing with the previous state. For whoever ever used Redux or similar paradigms, this should be pretty familiar. But let's look a little bit closer at this code. I mean, this stuff over here is pretty hard to read. It's not really obvious what it is doing, unless the only hint you really get is the name of that action. And in other words, how you could put it is that basically we solved the callback hell a while ago, and now we have new hell, and it's the spread hell. When we need to do a deep update, we are spreading all this stuff, and it becomes really ugly. I mean, just imagine that you're a historian 100 years from now, and you're looking at two pieces of code from this age. And somebody tells you, at a certain point, there was an evolution in how we wrote code. Now, what do you think was what we did first, and what did we do after? And I think the top one is much better at communication, communicating at what we're trying to achieve. You can compare it a little bit with this image. It's like you feel that there's something wrong, but you cannot entirely put your hand on it. So, can we fix that? Can we make it better? And yes, we can. There are several known solutions to that problem. One of them is like use a bunch of utility libraries. For example, we could be using immutability helper or immutable. And then you can kind of express with a kind of query language what kind of update you want to achieve. So over here, I'm doing a deep update, and basically I'm giving a path based on strings. And then you give a function on how to update. Or over here, this is basically a small client-side query language. In other words, we have to learn a new abstraction to make what we had previously simpler. And actually, one of those libraries actually states, the syntax is a little bit getting used to, though it's inspired by the MongoDB query language. As if that is a good thing. And the problem is like these things are hard to type check and hard to read, and it's like another abstraction. So let me propose something different today. let me write a proper reducer, or at least what I think a proper reducer looks like. So we are going back to this demo, and I'm going to make this reducer a little bit simpler. So I'm going to make it a bit straightforward, because what I want to do is update that relevant to do, take the tags, and push the right thing on top of this. This is straightforward to me. And then I throw away that chisel and that chisel. And so this is my proposal for a proper reducer. So let's talk about it. What is beautiful about this? Well, it's nice and short and clear and type checkable. Those are the good parts. Sadly, there are also some bad parts. What are the bad parts? Well, basically, it destroys everything that's good and beautiful about immutability. I mean, this is not immutable anymore. This is just side effectful stuff. So it destroys everything that we gained. In other words, we have to fix something. So let's fix this. And let's think about how hard it is to fix this problem. So just raise your hand if you think fixing this is going to cost me more than 20 characters to fix this problem. I see a few hands. Who thinks it costs me more than 10 characters? A few hands. Less than 10. Less than 5? I see one believer in this entire church. So let's fix this. So here's 1, there's 2. Oh, and I should show you that so our tests are failing now, right? That's what we are proving, that this doesn't get the right semantics. So here we go, 1, 2, 3. We save it and all the tests are succeeding. So how is that possible? Well, that is what Immer is doing. So what Immer does, basically, it gives you a way to compute the next state by just changing the current state. To write it a little bit longer, normally we don't call this thing P. That's just to stay below the 3 characters. Normally we call this produce. And produce has the signature that it takes some state and what we call a producer function, and then it produces the next state. So how does it look like? We call produce, we give it our current state, and we give it a callback function, which is called immediately by produce. And that callback receives one argument, a draft object. Now what you can do with a draft object, so it's basically the same state, the draft object. But the interesting thing is we can directly mutate it. And what Immer will be doing is it will remember what we did to the draft object and actually apply that to an entire new state. And since we're not really doing anything with this state, with the original state object in this draft function at all, we can query this and write it a little bit shorter. So we immediately say that our reducer is a producer. So produce takes just a producer function that returns as a function which accepts state, and then with the producer function with the recipe, it produces the next state. And so that is simply what this demo is doing. We're changing a draft, and when this function ends, when the reducer completes, we have a new next state, which is structurally shared with whatever we did before. And the old one is untouched. And so that is Immer in a nutshell. So it makes writing deep, complicated updates really straightforward. And the best thing is, it's just operating on normal JavaScript data structures. You never need to convert them back or forward. TypeScript understands them perfectly. It's just what it already knows. You get the structural sharing. And actually, if you want, you can get freezing and JSON patches for you out of the box. So this is really quite a change in how we can work with immutability in JavaScript. And so there are many applications, not just reducers, but also updating complex configurations. You can use it with React setState or useState. And basically, anything where you have to deal with an immutable data tree, that you can apply this mechanism. And actually, we see that it's gotten quite popular over the last half year. And if this trend continues, it will actually soon be more popular than immutable.js. In fact, recently there was even a conference where it got awarded. So that must have been a really awesome conference. And so, how does this all work behind the scenes? How is this possible? And what it uses behind the scenes is this concept of proxies. So let's dive a little bit deeper into them. The API of proxies is, in essence, pretty simple. You always call new proxy, and you give it 2 arguments. The thing it is proxying, and traps. And what it happens, it returns you a new object that looks exactly the same as the target you passed in, but every interaction you're going to have with that object, that's first going through any trap you make in the traps handler. That sounds a bit vague, so let's write the most simple proxy possible. Here I have created an object called Oracle, and I proxy just an empty object. And I define one trap, and the trap is get. Get is invoked every time you try to read any property from an object. And so this one is always going to return 42. So that means that I can ask the Oracle, what is the average temperature in Spain? And it'll say, oh, that's 42. Not entirely sure if it's correct, but at least it feels that way. Or I can ask, Oracle, what's the meaning of life? And it will tell me, 42. And I can invoke a function on the Oracle, and that will give me an exception, because 42 is not a function. But basically, you can trap every property an object has or is going to have. Whatever your code is accessing from the object, you can trap that. And so you cannot just trap reading properties, you can also trap writing properties, but also all the reflection APIs you can trap. So you can trap what happens if somebody is iterating over an object, or even what happens if he is checking what the prototype of an object is. You can even trap what happens if the thing that is being proxied is being called as a function. So that's quite powerful, also quite scary, but quite powerful. And the interesting thing is, proxies are completely undetectable. At least from code perspective, you cannot reflect and see that you're interacting with a proxy. That is entirely hidden to you. You can see it in the debugger, but not from your JavaScript code. So that means if I create a proxy on an array, and I ask, what is the type of P, it will not say, oh, that's an array proxy. No, it will say, oh, P, that's an array, of course. It's being proxied, but that is basically irrelevant. And so let's build a fancy example just to show what the power of proxies is. And for this example, we're going to use the Star Wars API. And so it's a very RESTful-oriented API, and you can ask for the people with ID 2 or the planet with ID 3, and then it gets you some data object back. And in typical REST style, the data itself can have references to other objects. So the characters is just a set of URLs, which in turn would respond with a description of that character. So we could basically write a contract in TypeScript, for example, that describes this very API. So maybe we get this from our backend guys or something like that. And so basically, the interfaces above, they describe how the API should look like. Now the question is, how can we build a proper implementation, a proper client that we can use from JavaScript and that implements this interface? Now, basically, you can take 3 different routes. First of all, you can just code this entire interface, this entire API by hand and write your own client for this server. That is a really good approach if you're a consultant. Secondly, you can generate entire client from Swagger. So that's like you give it the description of the servers, and then you get this strongly type generated client. That is the way I would recommend, but that's not the way that is fun, so let's not do that. No, you can also use proxies. So let's use proxies. Not because we should, just because we can. So over here, I have this interface in TypeScript describing my API. And remember, when I would compile this, it disappears at runtime. This doesn't exist at runtime at all. So I cannot like reflect on it at runtime because it doesn't exist at runtime. On the right here, I have a unit test. Is it big enough? Yes. And what I do, I create a REST client for this endpoint, and I upcast it to that interface. Of course, that doesn't work because like casting to an interface doesn't actually give you an implementation or something. So what happens if I call the API and TypeScript will tell me that this API has a films method because like I casted it to have one. But actually, of course, this is going to fail because there's no implementation. So that's the thing we're going to fix. So over here, I have my REST client that it's generic and it should be implementing this interface. However, it's just returning an empty object. Hence the error. So what we're going to do is like we're not going to write all those methods for films and movies and people and whatever there might be in the servers. That is the smart thing to do, but it's also boring. Let's just use proxies. And what we're going to do is we're going to trap all the interaction our test has with this client object, which is just an empty object. And so what we're going to do is when our unit test is reading a property from this object, we're on the fly going to generate an implementation that is able to make this request. So when we try to get the films method, we're just going to generate a new method that takes an identifier and it makes a fetch request to the URL we were providing. And the endpoint we need is basically the property we're reading. And then we append also the identifier to get the right one. And so that gives us a promise that produces some JSON. And so if I save this, and the internet is still working, now my unit test suddenly fails. So I have here an on-the-fly generated REST client that is fetching data from a real server, just by the mere fact that I'm calling a method on it, which didn't exist yet before I was calling the method. So as you see, like this test succeeds now, and it produces the correct planet. So that is something you can do with a proxy. But we can make it even a little bit fancier. Because when you look at the data structures that are being returned, they contain URLs, and they're just plain strings. That's annoying because then you get the URL in your hands, and what should you do with it? Well, then you have to fetch to discover what's in there. And we can fix that with proxies as well. So over here, I have a second test. And it first fetches a film, and then there's a bunch of characters in there. And I'm just going to write a proxy that instead of returning me the URL if I request for a character, it's going to make a request and return me the promise instead. That means that I can immediately await a certain character and get the object back with the response. And I can even go into like the home world of that person and get the name of the planet. And all the requests are made automatically in the background. Well, this test, of course, should fail initially because it's still just returning strings if we read something from the JSON, because that is what is actually in there. So let's make another trap. So what we are going to do is when we receive a JSON response, we're automatically going to trap every property read from that object, and if it's an URL, we're going to make a request. So for that, I introduced the trap URLs function. And so that's that value being passed in, that's just a raw piece of JSON. And I'm going to proxy that one as well. And what I want to do is that so I don't want to do this eagerly. I don't want to request all the things that are in the JSON. I just want to request those things that the code is actually accessing, so that I don't make like a million requests. So what I'm going to trap is I'm going to trap when a property is being read. And so I check so if a property is read, what value was there in the original object? The original being the JSON data, because that's the thing we're trapping. And then basically I have three possibilities. One, there's something that looks like a string, and it starts with like HTTPS, so it's like, oh, this is a URL. In that case, I want to immediately make a fetch and give the promise back instead of just this URL. So what I do, I just call fetch again, take the value, which is a URL, get the JSON, and then recursively apply this whole mechanism, because that JSON, again, might have URLs. So that's one case. And then the second case is I check if it's an object, for example, something like an array. Then I want to apply this proxy trap recursively. So then I'm going to trap that value as well. And otherwise, it's just another primitive, and I can return it. So now I can get some JSON if I try to read something from it, and that thing that I'm reading from it turns out to be URL, then I'm magically changing that URL or that string into a promise. And that's the thing I give back to my API. So let's save this. And that should basically do the trick. Yes. So now I have a completely chainable API based on random REST resources. And the cool thing is this entire client is completely generic. It doesn't know anything about how my Star Wars API look like. So that gives, hopefully, an idea how powerful proxies can be, especially if you apply them recursively to a certain process. And that very same mechanism is being used by Immer as well. So how you can think conceptually about Immer is as, who knows still what this is? A few people. So back in the days when I went to school, our teacher, they didn't have beamers, they used overhead projectors. And the idea is that they put some sheet on it which had some illustration or graphs from a textbook. And while they were explaining, they were typically scribbling on the thing. So they would be drawing on that sheet which contains graphs or tables or, I don't know, some system or a map. Now, of course, the trick they did is that they didn't actually draw on that sheet. Why? Because then after less they would need to throw it away and print a new one. No, so they didn't draw on the sheet. They just put another transparent sheet on top of that one, and that was the one they were actually drawing on. But we couldn't see the difference because they're both transparent, so on the wall you see the complete picture of the two things layered on top of it. Who knows that system? Who's seen that? Very few people. Not everybody had that smart teachers, apparently. Anyway, that is basically what Immer is doing. So you give it your current state, which is supposed to be immutable, and then you get a draft object back. And the draft object, that's just a transparent sheet on top of the original state you had. And whenever you write something to it, that's the thing you're going to see from now on. But the write doesn't actually propagate to the original state. It's just remembered for you. And then in the end, when the process finishes, at that moment, Immer will check what things you were using and what things you did change, and it will find minimal next state object. So if you put that in a graph, what happens is you get a proxy around the initial root of the state you start with. Only one proxy. And then like we did in the REST client example, when you try to read a certain property from that state, it's going to read it, but also creating on the fly a proxy around that piece of state as well. And it does so for everything you're trying to read from that original state tree. Now, as soon as you're trying to write to those proxies you got, it will remember that write, store it internally, and not actually apply it to the original. And so that is basically how Immer works and how it's possible to write completely mutable code which doesn't actually touch the state. So to summarize it quickly, basically, it checks like, do I have a proxy for this piece of data you're trying to read already? If so, I return it. If you modified it before, then I return the modified version. Otherwise, I just show you the original. And reverse also happens, like if you write to an object, it's going to create a draft next object, save the chains, and also notify all the parents in the tree, like, okay, these objects should be regenerated in the next state. So Immer is one cool application of proxies, but there are many, many more. So for example, you can create true singletons. So what you can do is, if you have a constructor function, you can trap the fact that it's called as a constructor. So that means that if you use this proxy, you pass it a class definition, and it returns you back a true class definition again. However, if you try to new it twice, you get back the same instance. So you get a true singleton. Or here's something else. You can make truly private properties where if you try to enumerate them, they don't show up. If you try to read them from externally, they don't show up. But if you try to read them from their own methods, they do show up. So you can make things truly private. Proxies are also used in both Vue and MobX to do change detection. So it means that once you write something to an object, it triggers the reactivity mechanism to notify all the relevant observers. And finally, there's this really cool package. It's called never-null, and you can basically give it an object. And after that, you can never get an error that says, cannot read undefined from yada, yada, yada. Why? Because whatever you try to read from it, and it doesn't exist, for example, I have an empty object, and I try to read the profiles.image, normally that would throw an exception in JavaScript. There are some proposals to fix that, currently in DC39, but this also fixes it, just by using proxies. So on the fly, it will just return you undefined, even if when you're like chaining into it indefinitely. And actually, if you try to write at an arbitrary place, it will just make sure that the objects needed in between are constructed as well. So that's pretty a fancy application. And you can do many, many more things with those magical things called proxies, like caches, infinite chaining, hot multi-reloading is a great application. That being said, proxy traps are a trap. Dutch people should get this joke. Somebody gets, okay, I'm not going to explain it. Bad joke, apparently. So they are a trap because they're like also quite dangerous. They can make codes very confusing very quickly. For example, if reflection doesn't behave consistently with how you implement it, people get really confused. Like, I can access a property, but it doesn't show up if I like loop over it. What is happening here? It's easy to get the whole this thing wrong. Also, proxies cannot be shimmed, so you cannot, in general, you cannot use them in Internet Explorer, for example. Although Immer actually has a fallback mode, which does work over there. So proxies are quite dangerous tools to use. I mean, they're like really powerful and really easily abused. So proxies, basically, they are a really low-level tool in JavaScript, mostly useful if you're like building frameworks or libraries. But I think they shouldn't end up in your normal application code. That's a place where you shouldn't be using proxies because you're going to confuse your colleagues. So To summarize, Immer makes working with immutability really easy. And proxies are really fun and really powerful. But remember, thou shalt not use proxy. Thank you.